Hello and welcome back. Today we're going to take a look at integration of the natural log functions, but this time we're going to take a look at what happens when we have trigs. So recall the antiderivative, that should be an antiderivative, of the natural log for the natural log function, we get this rule. The antiderivative of 1 over x is the natural log of the absolute value of x plus c. Now recall we have the absolute value because x has to be greater than 0, so we want to guarantee that. So if we take a look at number 1, this is just a warm-up for us here. If we want to take this antiderivative, the first thing I notice is if I look at the bottom, the derivative of the bottom, 3x squared plus 4x, is the same as the top. So this is our u substitution from the last one. So our u is going to be x cubed plus 2x squared minus 1. Our du being 3x squared plus 4x dx, and we get dx is du over 3x squared plus 4x. And I am just going to replace everything. We get 3x squared plus 4x over u and du over 3x squared plus 4x. Nicely, these cancel out, which is what they should. And by now we should recognize that this is our 1 over u, which is what we want. And that's our new rule. That's our natural log. So this becomes a natural log. Just don't forget your absolute value. X cubed plus 2x squared minus 1. And don't forget your constant of integration. Again, please remember your absolute values. For a question like number 2, this is where we talk about where we have the degree on top is bigger than the degree on bottom. So for this one, we're going to have to divide. So we're going to take that x plus 2 into x squared plus, put the 0x in there. There's no x in there, so you got to put 1 in there, minus 5. X goes in x squared, x times. When you multiply, we get x squared plus 2x. When we subtract, the x squareds cancel. This becomes 0 minus 2x, so negative 2x, and bring down that minus 5. We multiply x by negative 2 to get this negative 2x here. So we get minus 2, and I get negative 2x minus 4. And again, I am subtracting, so those cancel. The negative 2x's cancel, and I get negative 5 minus a negative 4, which is just a negative 1. That's my remainder, so this becomes minus 1 over x plus 2. Remember, we're not done. We're just going to rewrite our integral. This x minus 2 dx, this is the more complicated part, so I just write that part, except the 1 over x plus 2 is more complicated, so I just write that as another integral. So minus 1 over x plus 2 dx. Now the first one is pretty easy. That's just going to give us x squared minus 2x over 2 minus, but this one is our u substitution. We let u be x plus 2. Our du is just dx. So this becomes minus 1 over u du. Now notice we do have bounds on this one, but I haven't talked about them yet. We'll come back to that in a second. So here we get x squared over 2 minus 2x minus, this is our rule, natural log, and go ahead and put your u back in. It's just x plus 2. Now, because we do have the bounds, we're now going to use the FTC. Now, sometimes when we did u substitution, we would change our bound. But since I put it back in terms of x, I can just leave this as 0 to 3 again. And doing our FTC, f of 3 minus f of 0. This is going to be long and ugly. So let's have some fun here. Plug into 3. We get 9 halves minus 6 minus, plug the 3 in here, natural log of 5. Plug in the 0, we get 0 minus 0 minus the natural log of 0 plus 2 of 2. And there's your answer. Just leave it alone. Perfect. You guys did a great job there. The next one, let's take a look here. Now, I'm thinking u substitution because I got this little power here, so I'm going to go and do that. So we would get u equals x minus 1, du is dx, which is good. But when I write it, notice we get this 2x over u squared du. So, oh no, notice this is our algebraic substitution. We got to replace x. So x is just u plus 1. And I can write that, this just, and if I go really get, if I'm really good, this is just 2u plus 2 over u squared du. And I can split my integral. We're going to split it. This becomes 2 over u, because that becomes u over u squared, plus 2 over u squared du. And I'm going to rewrite this a little bit. 2 over u. Because my power is 1 here, I'm not going to rewrite this one. But that 2u to the negative 2, I can rewrite. The first one is just our natural log of u, plus, but this one's our power rule. This is power right there. I can add one. 2u to the negative 1 over negative 1 plus c1. Rewrite our answer. 2 natural log of u, which was x minus 1, plus, and be careful, I'm going to flip it, 2 negative 2 over u, which is our x minus 1 over u, plus c1. Oh, see how fun these get? All right, so let's take a look at some interesting ones, some triggerlicious ones. Let's get triggy. So for the first one, let's evaluate tangent of x, the antiderivative tangent of x. Well, we really don't know what this is, but I can rewrite tangent as the sine of x over the cosine of x. And now I'm going to use u substitution. My bottom has a power of 1. So I can say let u equal cosine of x. Our du is negative sine of x dx. Giving us dx is du over negative sine. When we write out a new integral, we get sine of x over u du over negative sine of x. Sine of x's do cancel, which is what we like. And what we're left with is this 1 over u, but don't forget that negative, so it's negative 1 over u du. And that's just our natural log. So we get negative natural log, because the power is 1, that's our natural log. U was cosine of x plus c1. So therefore we have a rule. We now have a rule for tangent. The antiderivative for tangent is a negative natural log of cosine of x. We can use the same skill for cotangent. We can get the antiderivative cotangent as being negative, as positive natural log of the sine of x. Where do we get the sine from? Well, same thing up here. Tangent was sine over cosine. So we get the cosine right there. Secant, we're not going to prove these ones. We get the secant of x is the natural log of secant plus tangent. I remember it because this way. The derivative of secant is secant tangent. So the antiderivative, I just throw in a natural log and a plus sign. That's all I do. Same thing for cosecant. Its antiderivative is negative natural log cosecant plus cotangent plus your constant. You have to memorize these. Okay, we have to memorize those. So let's try one. Ready? We want to take the antiderivative of the cotangent of 3x. We have an inside, so this is a u. U is 3x. Du is 3dx, giving us dx is du over 3. So when we try this one out here, we get 1/3 cotangent of u du. Well, the antiderivative cotangent is natural log sine plus c. So we get natural log of the sine of u plus c1, and just replace u. 1/3 natural log of the sine of 3x plus your constant of integration. All right, we're going to take a little bit of a break right now. We'll come back to part 2. We'll take a look at some more examples. I'll see you.